Perfect.
There we go, live. Hello, wonderful people, and welcome to episode 74 of the Web Platform Podcast. I'm your guest host this week, Justin Ribeiro. Eric and Danny are out, and by out, I mean they are shipping all the things before the holidays really kick off here. So today we're having a very interesting topic, the thing of Internet of Things, and today we're talking about JanOS and FirefoxOS, and we have Jan here with us. Jan, introduce yourself, please.
Hi, my name is Jan Jongboom. Not Jan, I'm sorry.
Sorry. My pronunciation is horrible. I should have asked that at the beginning.
That is totally fine. I'm Jan. I'm a Dutch developer. I'm currently working for Telenor. It's a Norwegian telco in their R&D labs. So for the past 3 years, I've been a very active FirefoxOS contributor. I've worked together with Telenor on launches in Eastern Europe and Southeast Asia. And about a year ago, I switched from doing full-on phone development to doing IoT. So JanOS is my fork of FirefoxOS, specifically tailored for the Internet of Things. But I also do proper embedded development. And on January 1st, I'm leaving Telenor. I'm joining ARM, the company that makes all the designs in all your phones, all the chipsets, and I'll be joining them as developer evangelist IoT. So now there's no way of escaping this whole Internet of Things.
And it is a growing field, isn't it? I mean, it's sort of taken things by storm over the last few years with the amount of sort of development boards we have, and sort of the hobbyist sort of recovery of electronics in general. I mean, how does JanOS sort of fit into that sort of picture of things?
So the thing is that, like, if you look at like what the big parties think of what the Internet of Things is gonna do, we're talking about way more than just this hobbyist movement, right? Here's the thing: if you combine all the Arduinos in the world and put them on a big pile, it's peanuts at this point compared to what the industry is pumping out. ARM only sold like 12 billion chips last year, and that's a start. I mean, if you look at the whole Internet of Things movement or like follow that, all the analysts like say 50 billion. That's like the magic number. That's what IoT is going to grow in 5 years. So the hobbyist movement, and that includes JanOS, is a really small portion of that. But it enables, the thing is that what we currently see in the whole IT movement is that stuff like Arduino, stuff like JanOS, stuff like new development boards enable to have a completely different type of developer come to the Internet of Things. Like traditionally, an IoT developer is an embedded developer. It's someone who studied electrical engineering. It's someone who knows what A around C, and that excites me most. That we can have like an ordinary web developer like myself, like started out 15 years ago doing VB in Internet Explorer, suddenly make this move into IoT, make this move into embedded. I think that's really cool.
Yeah, because it is hard to get started in embedded programming, right? I mean, we look at sort of the industrial systems that we have out there now that, what's for so long been called M2M, right? Machine to machine sort of things that, we see in a lot of plant operations or agriculture. But it's different now, right? Web developers have a significant amount of access to, burgeoning sort of new APIs that allow us to do a massive amount of more work across the board. And JanOS takes advantage of that, right? And FirefoxOS, which we're going to have to talk about the elephant in the room soon, is moving into IoT, right?
Yes. Yeah. So what I actually hope. So let me back up a bit. So JanOS is. So my project with JanOS started about a year ago when when I was looking for a subject to talk on during JSConf EU. So as like someone who was done his fair amount of speaking, there was like this one item on my bucket list, and that was JSConf. So I figured, like, let's do something completely crazy. And like as a longtime FirefoxOS contributor, we realized that FirefoxOS it's really cool. It's really powerful. It runs on phone hardware. It's pretty good at the battery. It has GSM, it has Wi-Fi, it has Bluetooth, etc. And the phones are extremely cheap. So back then we were doing the sourcing for our phones in Bangladesh, and we realized that for $24 we could buy a full phone, including the screen, including the battery, and including the chipset, and including like assembling all these parts. And on the other end, I was playing around with the Raspberry Pi, and adding GSM functionality to that thing costed me at that point €80 for a GSM chip. But this is completely out of proportion. Like really out of proportion. This is insane.
Well, it is interesting, right? I mean, bringing, you look at where the Arduino sort of started and along those lines too, right? Where, it was a serial connected thing that you operated against, and, you bridged it out and you did all kinds of things to get the connectivity you wanted. And then to add Wi-Fi on top, right? That was brutal. SAT or anything else was even more horrific. But you're right. The phone chipsets have sort of gotten significantly less expensive in terms of, and yet more powerful as well. Like you said, FirefoxOS does fairly well with battery. Battery is always a major problem when you think about embeds, and sort of the processing power that you have, not just that you have, but that you can actually utilize and still keep an up and running system. So you fork FirefoxOS. Well, I mean, what did you do to FirefoxOS to really make it more IoT friendly for the world out there?
So FirefoxOS, a really big part of it is the UI. But if you want to use this phone chipset as an IoT device, who needs a screen, right? So the first thing that I did was I took the Firefox code and I just removed the UI layer. That's it. Delete.
Refactoring's great when you can delete things.
It's fantastic. If we could pay by deleted lines of code, I would be extremely rich. So we did. I mean, like, remove it, and then suddenly we got a phone chipset that runs Gecko, like Mozilla's render engine, and it runs SpiderMonkey, Mozilla's JavaScript engine. So everything we could do on the phone, we could now do from code. So then the logical next step is, if we don't need the screen from code anymore, then also remove the screen like on a physical layer. So I got my screwdriver, and I started unscrewing the whole device and see when it would break. Surprisingly, it didn't.
And how many phones did you break during this phase?
In the whole process, I think I broke about 6 phones. But breakage is relative.
Exactly. Got to break a few things to make a few things.
If like after like being really active on a screwdriver and like most of the things work except for Wi-Fi, is that breaking? It's well, here we go. I mean, like, if I look at my adventures, it was actually surprising how far I got. So I mean, I got into this whole thing. I got an idea, I got the software running, and then like a week before JSConf, was like, okay, so now let's get this main board out and see if it still works. And for the biggest part, it did. So that was like a big win. That was a really big win.
And you've written a blog about this as well. I'll put it in the show notes, where you've basically wired out GPIO pins from phone chipsets by, basically gutting them. Which I find incredibly fascinating, by the way. Kudos on that. I love a good hardware hack.
So when I got this to work, so I got the phone chipset out of the phone. I got my fork of FirefoxOS running on top of it. You start to realize that you miss something. I mean, you miss like adding connectivity to these things. Developer boards are really great because they got GPIO pins where you can add new peripherals. So I was bitching against our hardware engineer, who has about 8 years experience in embedded development and lexical engineering. And he's like, yeah, but that's really easy. I mean, you just get like the Linux kernel, you change this and this and this, you reconfigure the GPIO port for like one of the buttons, and then ta-da, then it works. And like, and I'm like, this is so weird. And he's like, no, it's really standard. Like, everyone can do that. So he went ahead, and together we, in the Linux kernel of FirefoxOS, we repurposed 2 of the two of the buttons, the volume buttons on the side, because we did not need those to be output ports for GPIO. And like he binds it to it, he solders a LED on the phone chipset, and well, we can actually control the LED. And I'm like, this is so cool. We need to write a blog post about it. He's like, this is so standard. No one will read that blog post. Yeah. And we ended
But I
up
think it's a huge blog post. Like it's a great blog post, because I do think that it's very accessible. It's very hard to make some of these things accessible, right, into to the next phase of developers, because we could sit here and say, we can talk about the Linux kernel. I mean, I know a lot of listeners out there may have built it at some point or other, and if you've hacked on the Linux kernel before, yeah, you can make it do some amazing things with hardware. But is that really the next phase of things, right? I mean, in terms of like, are you really going to have to hack on the Linux kernel to make great IoT sort of platform stuff with things like JanOS or whatever FirefoxOS is going to be in the IoT field? Do you need to? Like, are we going to have those sugary libraries on top that are going to make life easier for us as web developers, or, the next phase of IoT developers?
If we continue to repurpose existing phone hardware, then for a little while we have to. But I don't think it's the way forward. So here, I mean, what I would love to see is one of these phone chipsets like on a proper development board. So if we look at like what Mozilla should do in terms of like their whole goal of like, so Mozilla, that's pretty cool that we have this this podcast planned, because just last week Mozilla basically canned FirefoxOS, even though they won't admit it, telling that they want to go like further into connected devices and things like that. I think what Mozilla is really good at this point is dealing with phone chipsets. I mean, they got FirefoxOS to run on it, they support it, they write kernel level stuff for it. I would love to have access to that power as a developer. If I can buy for $7 a complete phone chipset with Wi-Fi, Bluetooth Low Energy, and GSM, and then program that in JavaScript, that would be tremendous. I would way rather buy that than buy a Raspberry Pi, which is similarly powerful, but lacks a whole bunch of these connectivity things. So if Mozilla, yeah.
No. Yeah, no, you're exactly right. I mean, I think the connectivity proposition is key, because I do think people forget sometimes about the add-on connectivity portion, because not all connectivity is created equal either. We sit here and we talk a lot about sort of, oh, I have Wi-Fi. Do you have Wi-Fi, and what kind of Wi-Fi is it, and how much signal strength is that, and how much distance away from are you? And oh, by the way, how much is your interference? So like people, we sometimes make assumptions in our sort of connected environments, because we have, as developers, generally fairly nicely connected to environments, and then you go on the tube or the subway or wherever you are, and then things go south quickly. And IoT, depending on its use case, you can't have the south moment, right? Like disconnectivity can be rather brutal depending on what that thing is doing. And phone chipsets they give us a fair range of power against that. And JavaScript is fairly ambiguous, right? I mean, we have more JavaScript developers being, coming forward every day these days. It's a very, accessible language, and it goes back to that accessibility for the platform stuff.
Yeah. So to go back to the connectivity thing, it's also good to not underestimate how good the phone chipsets are in terms of connectivity compared to your average shield that you add to a Raspberry Pi. The first thing you'll notice is in terms of power consumption. A company like Qualcomm or MediaTek or Spreadtrum, the companies that make the phone chipsets, the stuff that you normally cannot buy yourself because you have to be a big original device manufacturer to get access to their blueprints. But compared to a GSM shield, they draw four times less current than a shield. And that's just because their radio interface layer, that separate operating system that does all the magic with talking to the base stations, is so much more mature. Because they can afford to put 100 engineers full-time just on making that better, because it's their competitive advantage. And that's insane. I mean, I would love to have access to that as like a prototype developer, as someone doing this for a living. And that's something we currently don't have.
And it'll be curious to see what Mozilla does in that regard as well. If they truly are moving Firefox OS, from this, phone sort of layer, with this GUI on top and sort of the phone operating sort of experience that we've come to expect into the IoT platform. I mean, it does shave a fair amount off their stack now and makes it, much more of a compact thing that simply runs against target hardware. And there is a powerful story around that in terms of what you can, assess as a developer and use.
Yeah, and the thing is that, say that again because I lost you.
Oh, sorry, I lost you as well on that last clip. But yeah, no, in terms of the stack itself, that's a powerful sort of story for developers because now you don't have to sort of worry about. You take the hardware equation out of it for you, right? You're simply dealing with an API stack, and when we think about it from an embedded developer standpoint, when you're dealing with C primarily or some other particular language for your PLC or whatever else you're developing for. That can be hard, right? I mean, that's not a very simple thing it's not very accessible to an end developer. But things like JanOS or Firefox OS or, whatever the next great phase thing is, APIs are going to be sort of the domain of, who comes to work on these sorts of things. I mean, do you see a lot of API development happening now on this sort of mature hardware stack that sort of made you want to do and say, oh, you know what, because of this mature hardware, I can make JanOS do exactly what I want it to do. And that's kind of what pushed you that way. I mean, why do it? I mean, there are so many other platforms out there now. Yeah. Is it strictly because it was running on that mature phone hardware?
So the project that I wanted to do after creating JanOS, so I got 3 months from Telenor after I presented JanOS to come up with some way that the company could benefit from this. And the thing that I really wanted to build is an IP camera that's connected always. The thing is that if I need to buy a phone chipset from a manufacturer in Europe, so not one of the big manufacturers, the power consumption of the thing is way too high. The speed of the chipset is going to be too low, and the price is going to be too high. So if I buy for $7 the chipset that we used in our Bangladesh phones, stick into a nice casing, I could take this little camera, because the chipset is really something like tiny, it fits in my hand, stick it somewhere on a wall, and then forget about it for 2 months. And this thing is just listening for me to wake up and send me a photo. Would be really cool. So this is something that is not possible with the hardware that we're currently having as embedded hobbyists or embedded developers at this point, because the only chipsets that currently have these characteristics, cheap enough, fast enough, and power and energy efficient enough, are the ones being made by the big manufacturers in China, the manufacturers that make the cheap Android phones. And that excites me. I want access to that. I want access to those chipsets. And they don't sell them to me because I'm not a big enough client. These are manufacturers that only want to deal with other big manufacturers. So, yeah, I mean, their hardware stack is so much more mature. And the only way of accessing this right now is by either abusing, for example, Android or Firefox OS and ripping the main mode out of these phones. So if you
I mean, it is hard to gain access to those things. I mean, in terms of mature stacks, because I think a lot of times it's nice that we have access to hardware, things like the Pi and Arduinos and everything else, Teslas, but going from that to a production level device is also very different, right? I can put it in a project box and make lights blink, but that does not make something that I can manufacture at scale or is going to, be kind to everybody's power consumption over time. Oh, I've plugged in 4 of your devices and my power bill has gone up astronomically. That's not a good situation. So, hopefully, in Justin's grand scheme of where will Firefox OS go, I can only hope that it gains us some access to sort of the stack of, mature sort of hardware that would allow us to do those sorts of things.
Absolutely.
So things like JanOS. I mean, there are things like the Tesla 2. You can run JavaScript on the Tesla 2.
Yeah.
Obviously, there are things like Node will run on a Raspberry.
Yeah.
How are they the same thing? I mean, is from a JavaScript developer sort of standpoint, like I want to do webby sort of things, and I want to use the language that I know. I mean, how does JanOS compare to those sorts of platform choices?
For a big part, they're similar. If I compare it to Raspberry Pi and Node.js, it's relatively similar to what we're doing with JanOS. I think the biggest win comes from how mature the libraries are. Especially things like properly do Wi-Fi over multiple chipsets, do Bluetooth and Bluetooth Low Energy in an energy efficient way.
Mm-hmm.
GSM, as said before, GSM is very hard to get right because you're talking to this coprocessor that sits in your chipset. It does all the actual communication, and having a commercial interface layer between those two is a lot of work. And that's all work where Mozilla paved the way. In a lot of other stuff, Node.js running on Raspberry Pi is a lot better because the ecosystem is way bigger. If I buy an accelerometer somewhere and I plug it into Raspberry Pi, there's like a 99% chance someone already did the heavy work of reading the data out of this thing. Of course, on both sides, this can be fixed. The thing that cannot be fixed, at least on Raspberry Pi, is the deep sleep. If I'm making a connected device, what's really important is to make sure that my device only is awake when I actually have something to do for it. Mm-hmm. So we just had the new Raspberry Pi come out, and there was someone in Hacker News who was really excited because he got power consumption down to 30 milliamps. The current, 30 milliamps current on a full circuit, which he thought was really cool. But at this point, the thing doesn't do anything. It's not connected to anything. And that means that in 50 hours, you suck down a normal phone battery. So it's useless if you want to use this in an IoT scenario where you just leave it and do some sensor readings or whatever. Whereas FirefoxOS or JanOS does a 0.1 milliamp or 0.2 milliamp current in idle mode. So similar to Raspberry Pi there. It's 300 times more energy efficient, and even connected to a GSM network, it only draws 8 or 9 milliamp per hour. So it's a bit of, I mean, that's where it shines at this point. If Mozilla creates a proper development board around it, a proper hardware kit, then we can definitely also do the ecosystem part there. That's what's really lacking right now. So that would be really interesting. If you compare it to the Tesla 2, the Tesla 2 is, I think what Tesla 2 did is really interesting. So the Tesla 2 consists of 2 processors. So on one hand, they bought from MediaTek a CPU, like a SoC, a system on a chip, that is being used normally in Wi-Fi routers, and that runs an embedded version of Linux. It kind of suffers from the same problems, so it doesn't have a deep sleep mode, so it always draws power. So they figured, let's add another processor. That's a Cortex M3, a microcontroller from ARM, that does all the hardware communications. So if you plug in an LED, it talks to the microcontroller. Then the microcontroller talks over a serial bus to the real processor. So when I type in a command in Node, I say blink this LED. It talks over the serial port to the microcontroller actually enables it. So theoretical, if they would implement the proper deep sleep, the whole system can be asleep, and only the microcontroller can run. And the microcontroller can run and listen for interrupts, like someone presses a button or an event comes in, could run that for years. So they don't have this at this point, but like that is a really promising technology. That means that you can, when it's needed, the device wakes up, it runs your Node.js code. But if it's not needed, it can do a proper sleep. The current can go even way lower than we can do on FirefoxOS at this point, and only wake up when needed. That'll be really, they're not here yet, but that will be a really powerful equation. I think if we're going to see JavaScript on embedded devices, it's going to be in such a setup. So microcontroller for interrupts, and then an extra processor that does the actual instructions.
And you bring up a very important point. You know, so much of what we, you know, when you start to work in IoT and sort of building devices that need to run sort of, you know, by themselves, they need to run under, you know, very low amounts of power. Power is problematic for a lot of reasons. One, power will generate heat, and two, power is, you know, you only generally have a limited amount of it, depending on what you're actually trying to accomplish. And this is kind of a new concept, I think, to a lot of developers who haven't worked on, you know, power-constrained systems. You know, you know, like you say, it's not quite here yet, right? We don't quite have these sorts of things that understand deep sleep. We don't have, you know, or at least in terms of readily available for sort of the current wave of developers coming onto the platform stuff. I mean, do you see that as sort of a problem for the entire sort of IoT sort of land of things when you start to look at, well, you know, I can run Node on XYZ, or I can run X language on whatever, but at the end of the day, is hardware our problem? I mean, do we need to be aware of these power consumption characteristics, or as developers, are we going to be sort of sugared out? And do we not need to worry about these because eventually Control Bard is going to take care of this for us?
I think that it's always like, look at like how we now get this movement on the web about we have to run at 60 frames per second, and we create tooling around that. It's something that has to be in your mind. When you do web, you need to think about like, okay, you got 60 milliseconds to do my whole render thing. When I do embedded, I need to think about the power characteristics of the device that I'm creating. It's a mindset problem in that sense. And it's not something we only see on the web, but we also see it on developers currently using Arduino. Almost basically every example that I see on the Arduino website does CPUs, like pauses the CPU by just having a while loop and then just like delaying. It's terrible. Yeah, the thing is that we're teaching developers the completely wrong thing. We should teach developers, like from the very first start, from the moment that you open up your Arduino or your Tessel book, is like, this is how you build a circuit. And instead of like being like sleeping for 1 millisecond and then checking if the button is now pressed, we need to tell people that you need to use hardware interrupts for this kind of stuff. So the device can just go into deep sleep at that very moment. And we don't. Like, power consumption is like chapter 12 of every book. You know, it should be chapter 1. Because the only way that we're going to make this Internet of Things thing happen is when I can create a device and leave it in the field for 2 years and not think about it. Because if I have to go back to the thing every 2 weeks, then after 3 times, I'm like, yeah, fuck this shit. I don't need this data anyway so bad. So let's just leave it at that. Yeah.
No, and I think that's a valid point. You know, a lot of, I mean, we have ag sensors that are deployed that you can't get to readily unless you go out into the field, and that could be a lot of time in a very remote part with, you know, some crazy hardware that makes this thing live. You have to make sure they're bulletproof in a lot of scenarios, and it's easy to build something on the bench that you can quickly sort of, you know, prototype or develop out, but that does not make production. You know, there is a great gap between those sort of things. And I, you know, in terms of the next wave of great things that we have in sort of this IoT land, the training does probably look a little different, right? I mean, we would need to, you know, developers are going to need to understand power consumption characteristics. They need to understand why the thing they're doing in XYZ language is, you know, not particularly performant or would give you great cause for concern. But when we talk about power consumption, then you start to also think about connectivity, because connectivity is often a huge equation to how much power am I going to use, and not all connectivity is created equal, right? We have things like cellular networks, we have long range, we've got Wi-Fi, things like that. I mean, how do you take that into account when you start to look at things either within JanOS or even in the future? Like how are developers going to have to handle that problem themselves, or do they have to handle it at all?
The thing is that you need to choose your connectivity thing based on your needs. If you need to be available from everywhere, that means you have to go with cellular. But that comes with its own caveats. So in general, if I think about connectivity, there's like two choices you can do. You can choose long range, or you can use long battery life. And that's like the choice that you currently have to do. So cellular on one hand, it's really good, always works up till kilometers, but it also means that like you can have the radio on for a week and then it dies. There's some tricks that you can do, like make the radio sleep straight away after transmission, and then you can like up the battery life to half a year max or something if you got big enough battery. But it only means you can only wake it up like 4 times a day, and that's going to be it. On the other hand, you got stuff like Bluetooth Low Energy, which is going to work for years on the coin cell, but then you got like the range problem. You have to be within range there. What I'm really excited about currently, what we're seeing is a whole branch of new sub-gigahertz networks that work in the free spectrum. And these are networks like LoRa and Sigfox, Weightless M. They all work from the same characteristics. They work in the free spectrum. So 868 megahertz in Europe, 915 megahertz in the US. So you don't need a frequency band. You don't need to pay the FCC money to be able to transmit there. But because the low frequency, it penetrates buildings and stuff pretty easily. And you use like a modulation scheme to make sure that from a device it answers at a gateway. And these things combine, they have different characteristics. So they do really long on a battery. So on like 2 AA batteries could run 4 or 5 years. They do really long range. Here in Oslo, we've seen 2 kilometers through buildings, etc., and 15 kilometers in open fields. But at a cost of both latency, which can be pretty high, and at the cost of throughput. This is like made for bytes at a time. So we got like 3 really interesting network technologies with 2.4 gigahertz networks like Bluetooth Low Energy, Zigbee, etc. On one end, cellular in the middle, and then we got stuff like LoRa and Sigfox on the other end. What people are the thing is they're not interchangeable. You need to like make a educated choice about this stuff. But that's something that people are not aware enough of. But I think we can solve that with better education, telling people about this kind of stuff. But it's not like a ready-made fix for this at this point.
Yeah, and then once you sort of make that choice, I mean, then we sort of get into the land of wonderful transports. And transports on the web, oh, I use HTTP and I have, TLS, yay. But it often differs quite a bit in the land Internet of Things, where you do have high latency and you can only push bytes. I'm a big fan of MQTT, for these sorts of scenarios, because you can pretty much run MQTT over anything. They have JavaScript libraries from the Eclipse Foundation, Peo, that does a wonderful job. That was from Roger's Mosquito project originally, way back when. Yay, Mosquito. So, I mean, but then when you start to talk about transports and how to deal with that at the sort of developer level of things, right now developers don't necessarily have to understand too much about this on the web, but once you get into the IoT side, you really do have to understand, right?
Yeah, I mean, a lot of companies are currently trying to get into this space. So, for example, Amazon launched their IoT platform, AWS IoT. Mm-hmm. And their premise there is basically, you tell us, like this device, the lights have to go on, or on this device it needs to read what the temperature is. But as a developer, you don't have to care about the transportation that's being used underneath. Just like if a user goes to my website, I don't care if he's on cellular or on Wi-Fi or I don't know, a pigeon that is printing out the page and flying him over. The browsers fix this for me. And Amazon, but also Google and Apple are trying to like find a position like straight into this ecosystem. So you tell us what should happen, and then we handle all the hard transportation problems for you. I think it's that part is really in land grab mode. Like everyone is fighting and jockeying for position. But I think that in 5 years' time, as like developers, as web developers, the only thing that we need to say is do this, and how that actually ends up at the device. Yeah, who really cares?
Yeah, because it'll come down to APIs, right? I mean, at the end of the day, web developers, live on APIs. Whether it's DOM APIs or some remote API that we need to use to sort of do the work, or shuffle data or whatever that thing may be. And APIs are consistently being added to the web now, right? We have this great expansion with things like Web Bluetooth and everything else, and transports and IoT is probably just one more API we'll have to deal with.
Yeah, absolutely. I mean, Google is like, I don't know if you've seen Google's new router, the OnHub.
Mm-hmm.
Google made this Wi-Fi router, but it's like a lot more. So it also does Bluetooth, and it also talks Zigbee, and it also talks Thread, and it will talk whatever other protocol Google decides to do aftermarket. So you tell Google, do this, and then what happens there underneath, who cares? So yeah, I think that's on an API level that will definitely be solved. Who is going to win there? I have no clue. But totally.
Yeah, I mean, there are a lot. It is very much the Wild West of IoT things. We've got, obviously Amazon has their IoT stack, which is based on MQTT. It's an extension of the version 3.1.1 from the spec. Google has Brillo and Weave, which is, they've announced, and there's some documentation, but no one's really seen it yet. Cisco's got CoAP. There's just a lot of players entering this mystical market with their particular wares that, as developers, it's never really been a better time. There is a significant amount of choice, whether it's open source or platform as a service or even API as a service, really now. I mean, does that change the way that we, developers should start to think about how they design these sorts of devices and the sorts of software that run on these devices? I mean, we've talked about hardware and power consumption and transports, but at the end of the day, like, people are going to have to use them, generally more than not. I'm going to want to see someone ring my doorbell and the picture from that thing. Does it change developers' perspectives?
I mean, on an embedded side, actually, absolutely, because what currently everyone is doing is making their own proprietary protocols for the last mile.
Yeah, that's no fun.
And they like to own that. I mean, just look what Philips did today with their U lights when they decided, well, so the last mile between the U router basically and the actual lights is owned by Philips, and then they decide, well, now we don't want anyone else on this thing anymore. It's ours. It's our proprietary platform. That is like a weird situation to be in.
It seems short-sighted, doesn't it? I mean, to me, it seems a little short-sighted. I mean, your vendor lock-in is tough, given the amount of sort of devices that you look at sort of now. I mean, Nest is probably a good example of this to some extent. They have Nest Connect. As a developer, I can access Nest Connect and make it work with my other sort of devices. This seems like a match made in heaven. It works with my washing machine, for instance, which is pretty cool. Because why not? I don't want to have to think about anything anymore in the wonderful world of IoT. But yeah, going vendor purely lock-in of like, this is my last mile. Yeah. You can't play in this, you don't get to play in our playground. to me, it seems a little short-sighted, given the amount of devices that are going to come onto the market, the amount of developers who are now building these sorts of devices. It's going to get crowded, and you might want to play.
For the two technologies that I think have the most, like, purely talking about smart homes at this point, the two technologies where I think that might be the technology for the future are Thread. There's like a big consortium of companies that are behind it. It's a bit Zigbee-ish, 2.4 gigahertz. And on the other end, Bluetooth Low Energy. All of them have the concept of profiles. So, for example, a heart rate sensor can implement a battery profile and a heart rate profile. And these are standardized by like working groups. If we can get Bluetooth Low Energy enabled lamps that implement the lamp profile, then it's open after that. I know that when I talk to something that's the lamp profile, then I can like flick it on and off, or I can change the saturation of the thing or whatever. Given that both Thread and Bluetooth Low Energy are now moving into this direction, that's like a big thing. I mean, like a first step into standardization of a whole area of like IoT devices. That'll be great. I mean, if we can get that, and I could just like enumerate, like give me all the devices that implement lamp on off, whatever. Then
well, and they showed a demo of that at Chrome Dev Summit this year with Web Bluetooth, and it was pretty. It's pretty trick. Like it's, it is a different way of interacting with your world, so to speak, and the sort of proposition that things like BLE in particular give you, because it is a sort of different sort of connected thing. A lot of times when we talk about IoT, we talk about, the cellular network and things that are deployed in the field, and they're always going to run for 10 years or whatever, because that's the sort of things we've built in the past. And I'm as guilty as that as anybody. But the BLE actually gives you an entirely different sort of user experience, right? I can walk up to something in this physical web sense of things, connect to it, interact with it, and then disconnect and be done. And because it is that sort of low distance sort of thing, there's not a high degree of, chance necessarily that someone's going to just magically, sit outside my house with a high gain, try to, flicker my lights for lack of a better term.
Yeah, I agree.
The entire problem not necessarily solved.
The problem is getting a bit worse if you look at stuff like that. So what we're adding in Bluetooth 4.2 is mesh networking between Bluetooth Low Energy devices, like vastly expanding the range, which is really good from a user standpoint.
Oh yeah,
because all the devices can talk to each other, and your phone is like the router. So wherever you are, suddenly like this whole network is being created. But yeah, we also need to fix something on the encryption level there. So at least the Bluetooth working group is doing that, adding encryption to BLE and Bluetooth 4.2. But it's one of the interesting problems to solve. I talked to someone who's really active in this space. He says, yeah, the first company that invents like the green lock for IoT devices secure, that's going to be big. But no clue how to achieve that at this point. How do we know that this communication channel is being secure?
Yeah, security is problematic. I mean, especially when you talk about constrained devices. It's to some extent we sort of take TLS for granted on the web because it is, for lack of, well, I don't want to oversimplify it, but it's not too hard to set up in most cases these days. You should set it up. Please put TLS SSL in your web properties, please, for the love of your users. But on constrained devices, that's actually quite hard. You can't exactly put TLS on an 8-bit controller and hope for a good day. There are ways around this, so to speak. Depending on how your network is controlled and whatnot. But it is a very difficult problem to solve. And yeah, that's an apt analogy. Whoever wins the green lock for Internet of Things wins the Internet of Things. I'm going to put that on a shirt.
Excellent. No, yeah, it's also it's a matter of trust in that sense. I mean, we decided, all of us, that we trust our web browsers, and our web browser, the way of communicating with the outside world. But in IoT, there's so many different protocols and apps and stuff, and how we connect to this. So it's, I don't know who to trust at this point in the whole IoT space. Yeah, and
yeah, no, it is a trust problem, and I think that's, you know, we've seen sort of, because again, it's not like this stuff hasn't existed previously. I mean, if you've been in the industrial sort of side of life, you know, M2M IoT sort of has been around for a while. There's been lots of, you know, proprietary things and other things that you can build within whatever infrastructure you like. But in terms of a consumer standpoint, it is a different conversation. Security is problematic. You know, people don't, you know, they want to feel secure in using their particular thermostat, or if they're, you know, for whatever reason, their refrigerator is connected and telling them some amount of data from that thing, that someone's not, you know, man in the middle in that, or you know, you're not bleeding data out over this sort of, you know, strange connection that you don't quite understand why it even exists. It's a problem to be solved, that is for sure.
Absolutely, yeah, and I think it's also like the convenience. And even protocols like LoRa, one of the long-range radio technologies, have end-to-end encryption built into the specification. But even there, you see that people think that giving every device a separate set of keys, which is required for this thing to be secure, is like too much work. And suddenly we see every device coming out with the same keys because those were in the reference project on GitHub. And
yeah,
brilliant standard, and all devices in the world are insecure. It's a usability problem as well.
Yeah, no, and I think it goes to tooling, right? I mean, tooling needs to be better in terms of, you know, sort of the next phase of development on these things, because I think we take for granted sort of the tooling that we have. And the web is interesting because the tooling seems to flip over every 2 years. You know, one day you're using Grunt, and the next day you're using Gulp, and then the next day you're using XYZ. Because it always seems to be, you know, the web moves at, you know, just a lightning pace of change. And yeah, I mean, you know, when you see sample keys that are duped out on devices that are cloned out from a hub, or, you know, a GitHub repo, is painful to say the least. Because, you know, you question, one, did you not understand the security implementation of that? Or two, was the tooling so bad that you simply didn't understand that that's what it was doing? And those are both bad questions from a developer standpoint, right? I mean, we need better tooling around that sort of equation to handle that for us. Otherwise, people won't trust the sort of devices that we deploy. And who can blame them at that point?
Yeah, I think that's why one of the reasons that I'm now going to ARM. So, like in half the IoT devices that are currently coming out, or devices that we see as IoT, there's an ARM microcontroller in there. So it's like a really good place to start working on the ecosystem around this and like making the tooling better. So the team where I'm going to work, the IoT/embed team, is like really, it's a tools team. Like we want to make embedded development. Like if you're still like one of the embedded developers that does C, if you need to get 5 years out of your battery, if you do industrial designs, etc., we want to make the world a better place for you. So some stuff that we ship, for example, is a TLS library by default that runs on 64K of memory. So if you buy this $1 microcontroller, you can still do proper TLS, but also your build tools better. I mean, if you're currently an embedded developer, you're based and you buy an Atmel chip, or then you buy into Atmel's ecosystem. Atmel Studio only runs on Windows. You know, I'm walking around with a VM just because I'm doing something with an Atmel chip at this point. The documentation around the whole thing is horrendous. So people will find something and are like, yeah, well, this kind of works. Okay, I don't even need to check the defaults because I don't understand it, and let's ship it to 1 million devices. So I think there's a really cool challenge. Not really JavaScript related, but it's tooling related for embedded software, it's a really cool challenge that that we can take on in ARM. And ARM, as like the market leader, as the maker of these microcontrollers, can play an important role in it.
Yeah, and I think I think that's I think that's where a lot of this is going to head. I mean, it is somewhat pleasing to me, only because I know how poor some of the tooling is on that side. And now with things like JanOS and FirefoxOS and sort of this next great wave of things that can run on really great classes of hardware with very little power consumption and a significant amount of connectivity, that's a very, very powerful story for a developer who, started off in a browser somewhere and now is, well, I want to know more about these things. I want to connect and create great progressive web apps so that they can control them. But I also want to control that thing myself. I want to define what it does. And that's I think that's going to be a powerful story. Yeah, go ahead.
I think that what we're currently doing with all these web developers flocking to embedded is also an incredible learning opportunity for the embedded world. I mean, if we look realistically, if we look at like this 50 billion devices shipping in 2020 or something, if you're lucky, or even if you're like a big JavaScript family, maybe 1% of these devices will run JavaScript. Like by far most of this stuff will still run C or compile C++ or anything. But we know how to do tooling in the web community. We know how to iterate and how to make developers' lives a lot easier. And that's why it's super interesting to see everyone flocking here and trying to solve embedded problems in a web developer way. And I think we can learn a lot from that. I think that's why it's like a blessing that everyone else suddenly thinks IoT is really cool. Because there's so much to learn.
Yeah, no, there is a great deal to learn. And I think the sort of the cross-platformy teams coming together to say, let's solve problems as opposed to fight each other over, XYZ thing is always a better use case than just, simply to sit there and, argue about, whose programming language is best. Because at the end of the day, we all have to ship. Otherwise, generally, people don't hire us. So... So we're running up against time, Jan. What have I absolutely missed that you would like to tell wonderful peoples about JanOS, FirefoxOS, anything in the embedded platform things?
If you wanna play around with JanOS, and I highly suggest you should, and you have an old FirefoxOS phone laying around, there are builds available for most of the popular phones, including the Geeks phones that have been like spread out over the tech community 2 years ago, but also for the Flame, the official reference device for FirefoxOS that used to be out there. So if you want to see how doing a bit of embedded development on a mature platform looks like, if you have all this JavaScript power available to you, then definitely go ahead. Like, give your FirefoxOS phone a second life. Website is janos.io. Got builds available there, not just for FirefoxOS, also for Nexus 4 and for the Galaxy S2. And if you flash the thing, like open up your casing and rip out the mainboard, it's actually really fucking fun. it's
all the things is the main kicker to take away from today.
Yeah, absolutely. It's the most fun I've had in years of development, like toying around with this stuff and finding out things. And for me, it was this stuff. What it did here was for me the step to do like full-on embedded and start making production devices. Like just last week on Thursday, we got our first self-created sensors that took long range out of the factory. That's that feeling is freaking amazing. Absolutely. So I hope some people get inspired by it.
And where can they find you on the socials? Are you on Twitter, Google Plus, the Facebooks?
I'm not on Google Plus, but on Twitter, Facebook, GitHub, Lanyard, etc. I'm always there on Jan Jongboom. My website is janjongboom.com. If you want to contact me or send me an email, feel free.
Well, fantastic. Thank you so much for being on the show today, Jan. It's been a pleasure.
Thanks for having
And
me.
this has been episode 74 of the Web Platform Podcasts. I believe this is the last podcast of the year, so we will all see you in 2016. Have a very happy holidays, everybody.